Welcome back, Patriots. I am the Math Patriot, bringing you another video in the great and exciting world of high school geometry. Starting up a new unit today, we're doing trigonometry, and this is one of those places where, honestly, if you talk to your family, if you talk to your parents, you talk to your aunt, your uncle, they're probably going to have a bad taste in their mouth over trigonometry, because in the past, teachers haven't exactly presented this stuff very well. And I'll be honest, it can be difficult, but it can also be pretty easy provided that you approach it the right direction. So that's how we're going to do this. We're going to step through it, take baby steps all the way through. You know, this stuff, you can look at the surface or you can go down miles and miles deep. And we're going to stay pretty surface level with our analysis of trigonometry because, I mean, the scope of our class right here is basic high school geometry, core geometry. We're not going into all the really deep stuff you're going to need for physics or for marine biology or any of those crazy, not crazy, but really in-depth uses. We're going to be sticking on the surface, and we're going to go step through this thing pretty easy peasy cheesy. Now, if you haven't done so yet, go ahead and hit that subscribe button. We're going to have a lot more videos on trigonometry coming your way, and we're going to go ahead and finish out the rest of the year for our curriculum here in Texas. So first off, what is trigonometry? Well, trigonometry is a branch of mathematics studying the relationship between the sides and angles of triangles. Now, that's a whole bunch of gobbledygook. I mean, let's just break it down and see what we got here. I've got two triangles. Now, we got to be looking at a relationship between our angles and our sides. These were meant to be similar triangles. I'm sorry if I got a little bit off, but let's just say that these guys were 9, 12, and 15 on our side lengths, and that over here we're at 6, 8, and 10. Now, first off, we just finished up doing a unit on similar triangles. And remember, for triangles to be similar, we have to know that they have congruent angles and that they have to have sets of proportional corresponding sides. So let's first off look at these proportions of sides. So let's go ahead and take our left-hand side. We've got 8 over 12. That is going to reduce down to 2/3. Our bottom side is going to be 6 over 9, which again reduces to 2/3. And our hypotenuses are 10 divided by 15, reduces by a factor of 5, down again to 2/3. Now, since all of these ratios reduce down to the exact same, that means that we can say we have a scale factor of 2/3. Our sides are proportional. We know that we have corresponding proportional sides. Now, because I have a side similarity scenario here, what that means is that I know that my angles have to be congruent, all the corresponding pairs. Now, I already drew in the right angle in both of these, so you know that those are congruent. Now, I'm going to take this acute angle here on the right, and I don't know what that measure is, so I've got to use a variable for that. Now, typically we use x as our common variable in just about every single application in mathematics, but trigonometry does things a little bit differently. We're going to use the Greek letter theta. That looks like an O with a horizontal slash through it. Okay, so anytime you see that, it's a theta, and using English characters is pronounced Theta, theta. Now, I know that these guys are congruent, and also these up here are congruent. I'm not going to mark those though, because you know that if we have 90 in theta and 90 in theta, then these two have to be equal to each other as well. But the purpose of trigonometry is to look at what's the relationship between this angle and the sides, or the other three sides around the triangle. So I'm going to go ahead and make another 3 set of proportions. Okay, I'm going to look at what's the ratios within with the sides within a single triangle. So let's take here our bottom and our left side. 9 divided by 12. Well, that reduces down to 3/4. Now that was bottom and left. Let's do bottom and left over here. 6 divided by 8 also reduces down to 3/4. The exact same ratio occurred on both triangles. Now let's try that with our left side and our hypotenuse. So if we have 12 divided by 15, that is going to reduce down to 4/5. Over here, 8 and 10, 8 divided by 10 reduces down again to 4/5. Well, let's try it for our third set. Let's do 9 and 15, the bottom and the hypotenuse. 9 divided by 15 is going to reduce down to 3/5. Also, let's do 6 divided by 10. Once again, reduces down to 3/5. So since I have these corresponding ratios that equal each other, that means that there is some form of relationship between the sides of this triangle and the sides of this triangle. That discovering that relationship, trying to figure out what the patterns are going back and forth between them, that is the core of what trigonometry is about. Now, that's the tip of the iceberg. We're going to be spending a whole lot of time going over all these different ratios, how to come up with them. Should we do this opposite, adjacent, hypotenuse? We're going to be naming our sides, coming up with different fractions, figuring out our 3 trig functions, all that sort of stuff. But don't worry about that for now. For now, just realize that all the trigonometry is looking at the fractions of sides. Now, where in the world are we going to go with this? Okay, well, me in particular, I'm not going to go all this distance with you, but there are places you could go. So what all is trig used for? Well, there's applications for indirect measurements. Now, indirect measurement is when you're trying to take something extremely large or extremely small and measure it using simple tools. So how do you measure the pyramids using nothing but the distance from the ground to your eyeballs and also a protractor? Okay, you could measure how tall a pyramid is doing that. We could also go with a sonar system. Okay, the basics of how a sonar system works are going to be tied up all in these different angles and ratios. Video game editing, particularly video game graphics. I remember once I was working a job outside of teaching. I was actually doing a programming job, and I was having to help a developer come up with how to place certain points around a circle that were dynamic. So he had essentially a crosshair here, and he had to make dots around a circle, but these things had to be able to move. So this guy could move up to here. You could drag this guy down to here, and to make this kind of bizarre oblong circle-ish shape, he was trying to design all that, but he had to use trig functions in order to place every single one of those 24 dots around the circle. So video game graphics or any sort of computer graphics is going to use trigonometry quite extensively. Physics is going to use extensive use of trigonometry, and these ratios are going to come up all over the place. So, like I said, just an introduction right now. We're not doing any real math as of yet, but here in the next few lessons, we are going to go on to how do I name these sides, what is opposite, adjacent, hypotenuse, the 3 names of the sides of a right triangle, how do I make these ratios, and then how in the world do I use those to actually come up with some of these actual real applications. So that's it for now. Everybody, once again, if you haven't hit subscribe, go ahead and hit that subscribe button. And as always, stay patriotic.